Alright, okay, this will be another type of function which is a polynomial function. Okay, it seems like it's the same as the previous function, but there is something that's special in this function here. So of course we want to find these cases here. Okay, I'm going to use the second derivative test first, followed by first derivative test. I'm going to tell you why. So f prime x, so you differentiate this function, you will have negative 4, okay, 4 times 3 over 2, you have 6, right? You have negative 6x to the power of 3 plus with 24x to the power of 2. Okay, so you will have negative 6, 2, 4, 2, 2, 4, 3, 2, 6. So, and this one you have 3, 8, 24, x to the power of 2. Differentiate negative 1, 0. Okay, so of course, I want to find the critical point. Alright? Critical point for polynomial function is always the stationary point. Okay, it's always the stationary point. So it means that you're just taking this equals to 0. Don't need to consider about f prime x is undefined. Okay, it will never happen. So then you're taking negative 6x cubed plus with 24x squared to be equal 0. Right? Factorize negative 6x squared. I think it's the best. You have x minus with 4 equals to 0. Right? So you factorize negative 6 x cubed negative positive 24x squared, right, equals to 0. So negative 6x squared equals to 0 and x minus 4 equals to 0. So you will have x equals to 0 and x equals to 4. There is only 2. For these cases here, this is a power of 4, but it only have 2 stationary points, okay, 2 critical points. So, and for this case, okay, I'm going to use the second derivative test. Okay, the second derivative test. Test. Okay, let's see what happened. As you know that in the previous video, I have already explained about second derivative test. So I have to derive this for second time. So I derive, I have f double prime x. Differentiate again. So negative 18x squared, right? Plus with 12x. 48x, right? 48x. Because 3, 6, 18 become 2. This one, 48x. So then for these 2 points, x equals to 0 and x equals to 4, I'm going to substitute into this second derivative to do a test. So I'm finding out that something happened. I'm getting 0. This is the one that I said special. Please notice that. So why? You should know the answer before I telling you. So f prime 4. So if you're putting 4, what happened? Alright? So you have substitute 4. So I have negative 18 alphabet x squared plus with 48 alphabet x. So I calculate with 4. So I will getting a negative number. I substitute with negative 18 4 squared plus 48 4. I will getting a negative 96 here. So means that only this one will tell me 4. So this is 4. So if you substitute 4, okay. Sorry, you have to substitute. So I want to get the coordinate for this. So y is equals to what? Negative 3 over 2, 4 to the power of 4, plus 8, 4 to the power of 3, minus 1, right? So we're getting the value of y first. Alright, so I think you are getting the number of 127, right? It's very high. So it's 4127. For this, I can making a conclusion. I already can making a conclusion. Why? Because this, right? Sorry, because this one, the second derivative test, you substitute into the second derivative for the 4, you're getting a negative number. A negative number, you remember, if you remember second derivative, if this is a negative number, it will be a maximum point. So if positive number, it will be a minimum point. If equals to 0, what happened? The test is failed. Right? That's why I'm doing first derivative test for you first. For these cases, I want to tell you why. So 4 is a relative relative maximum point, right? Why? Because from the test you can see it's negative here, but this one cannot tell you. Means this is not maximum and not minimum. It's not a maximum, it's also not a local minimum point. Then what is this point, right? The question mark is here. What is this point? That's why we have to do inspection. Kita kena check, menyiasat, siasat, okay, siasat. Apa yang berlaku ketika x sama kosong, okay? What is happen when x equals to 0? So why the test fail here? So means now I'm going to doing the first derivative test. Right, so means that first derivative test is more powerful. Okay, let's see how to doing the first derivative test. But please copy down this and remember what I have already talked about. Right, so now I'm going to use here to writing for first derivative test. Okay, now I'm going to talk about first derivative test. Okay, because the second derivative test is failed in these cases here. Okay, because the test give you a 0, it cannot tell you this point. Okay, we don't know this point is a maximum or minimum, we don't know. Alright, so I have 4, 1, 2, 7. I know that 4, 1, 2, 7 is a relative maximum point. And for 0, I have to find the coordinate first. So when I'm putting 0 here, 0, my y value will be 0, 0, and I have negative 1, right? So it means 0, negative 1 is an unknown. Okay, I don't know what is happening. So I'm going to do the first derivative test. So I draw the interval, which I divide them to 3 regions, okay, which is 0 and 4. So 0 and 4, these 2 points here. So then I'm doing the test, okay, I'm doing the test. So here is from negative infinity up to 0, and this is for 0 up to 4, between 0 and 4. So this is from 4 up to infinity, alright? So this is the interval of x, right? We write properly when we do the test, interval of x. And the sign, we want to inspection. This is actually an inspection method. First derivative is explained, kita observe. We observe what is happening to the sign of f prime x or dy dx and the shape of tangent. Okay, shape of tangent. So then now we're going to talk about the sign, right? So of course this is a first derivative test. Okay, ujian penerbitan pertama. So if you look at here, f prime x, right? F prime x. So this is the one. Okay, I'm going to key in into my calculator, right? So I have negative 6 alphabet x shift cube, right? Negative 6x cube plus with 24 alphabet x square, right? So you look at this, you have negative 6x cube plus with 24x square, right? Negative 6x cube plus with 24x square. So now I'm pressing the button calculate, right? Choose a number negative infinity up to less than 0 lah, for easy, okay, less than 0. You choose negative 1, right? Choosing negative 1. So I choosing negative 1, I pressing double equal, then I will have positive number here. I don't take the number, I just want to know the sign. It's a positive number, alright? This is a first derivative test, so I have to know the number. So now, alright, so then I calculate for a number between 0 and 4, I can choosing 1, calculate 1, double equal, then have positive number again. Can you see that? In the previous video I talked about, doesn't mean here positive, here be negative positive, or negative positive negative, positive negative positive. No, okay, it's not going to alternate. Okay, this is mathematics. Mathematics we talk about logic. Okay, logic. Okay, we never talk about we must talk about logical reason. So positive here, and again by using the calculator, I substitute the value of 1 into the function here. Right, I substitute 1 here, I getting positive again. This something happened here. That's why the test is failed. 0. Do you remember that? Just now the test is failed at 0 because something happened. So 4. Here I for sure is a negative number here. Why? Because it's a relative maximum. So I calculate a number bigger than 4. Bigger than 4 will be 5. So 5, you're pressing equal. Then you have negative number, right? For sure. Why? We talk about this point first. We talk about 4, 1, 2, 7, which is the maximum point. Why? Negative, right? Negative. Positive, right? The gradient. So if you join, it's a relative maximum point. Second derivative text already tell you it's a relative maximum point. But this one, something happened, right? Something happened. So where it's positive and positive again. How come, right? How come? So, but we can know something from here. Okay. So this is if you look at this one is a maximum. Maximum, but this one you cannot, it's not maximum, not minimum, but I know the graph will be this way. The graph will be going up, okay, going up, and during zero, it will be stationary. Stationary. Do you know that this point is a stationary point? Stationary point. So even though this is a maximum point, but here is a stationary point. Stationary means berhenti, pegun, dia pegun. Alright, so this case is pegun, pegun, tak bergerak. So then later they go up again. Can you see or not? This one, and they go up again. They go up again. Then this one doesn't show is a relative maximum minimum. Bukan maximum, bukan minimum. So this type of point, we set it to be an inflection point. Okay, for your extra knowledge, this is for your extra knowledge. This is a inflection point. Titik lengkuk balas, alright, where they never become they never turn. It's not a turning point. They never turn, okay, or they never go up or they never go down. Okay, it's not maximum minimum. It's a inflection point. Alright, so this the graph. So means that 0, 0, -1 is not an extremum point. Alright, it's not an extremum point. Why? Extremum means maximum minimum, right? Maximum minimum here. So it means that the first derivative test has already tell you. So now I'm going to sketch the graph for you and you see what is going on. Alright, let's continue with graphing. So I have only these 2 points. These 2 points very important. So 0, -1 is 0, -1 is don't know. It's not maximum, not minimum. It's not an extremum minimum. So it's not turning up or turning down. No. So, but for that 4, okay, 4, 1, 2, 7. Never mind. We just sketching. We just put somewhere here. Alright, sketching roughly. So 4, 2, 7. And you know this is a relative maximum point. Maximum, right? Turning point. Alright, it's a stationary point here. So, and this is also a stationary point, but it's not maximum and minimum. Alright, it's not a turning point. So you see how I draw the graph. Very easy. You see the graph going up, and passing through 0 and going up again. So this is the meaning here. Alright, you try to see how I'm drawing. So it's going up, but it's stopping a while, right? During here, if you see the particular point here, it's stopping a while. So then they're going up again. And reach the maximum point and going down again. So this is the graph for the function. Okay, this is the graph for the function of fx equals to -3/2 x power 4 plus with 8x cubed minus 1. Where there is only this graph is only one relative extremum point, which is a relative maximum point. So if you see it here, of course you must drawing such that it's horizontal for a while, right? This is a special point here. So it's going up and they stop a while and then going up again and reach a maximum and going down, right? So this is the beauty of the graph, right? Okay, so that's all for this video. So we will discuss more about relative maximum in the next video.